When you're dealing with something as complex as building a rocket or as building a launch pad, being extremely mindful of the critical path is important. And what the critical path is the longest set of sequential events that are gated by each other that must be completed in order for a task to happen.
Attention all operators on LVN0, we're getting ready for a pre-op brief for Flight 12 here. We're going to start off with some comm protocol. T-minus 1 minute.
When we see an unexpected response, how confident are we in being able to explain that, such that we're not unknowingly walking into an actual bigger problem that this was just a small symptom of?
Holding at T-minus 40 seconds.
Yes, sir, got you.
This looks like a blip on blind pressure when we unpinned. Pressures and preloads are healthy.
Copy that. And what is the time we would unpin at? Okay, copy, agree. We should attempt again.
On LVN0, ship QDZ actuator blowing outside QD vent pressure range.
On anomaly 0, tower curry, I think I'm going to recommend actually stand by. It's drifting back into range.
Is it going to fire again, tower mech?
Possibly. It seems like it's part of the dynamics. When
Copy.
There's a pinner that keeps QD on from the whole QD on when it swings back. There's a pin that locks it into place. The hydraulic actuator is not pulling it up, it seems to be.
And Elon is actually really, really good at quickly absorbing information, understanding the stakes, understanding the consequences, understanding if today's our day or not.
Yeah, it's hard to tell. This is all fogged up from cryo, but it's essentially right there.
Tower Steyr, are you on anomaly 0?
Yes, sir, got you.
I don't have an explanation for why it did not unpin the second time.
I personally have never felt any pressure from Elon of like, it doesn't matter, hell or high water, we're flying this rocket. Like, absolutely not. That's not his style. And like I said, critical path to Mars is not blowing up rockets.
Guys, I recommend we release hold and give it one more chance to unlatch with where we're at.
Ship XYs are not going to close out and damped, but I believe that's okay.
Okay, we have just enough time on the vehicle to attempt one more time, so I recommend we clear the hold, let it try to unlatch it at the 100 bar we're at.
We're still stuck in dampening though.
Understood, we'd be reattempting with the same hydraulic pressure. Cool, this will be our last attempt and then we're done on the rockets.
When we're only a week out from flight, my main focus is getting into flight. The thing that separates us from a lot of other companies is that we test fast and we test often, and that includes launches. We want to make sure the vehicle's all ready to go, we want to make sure the ground's all ready to go, but we also don't want to be caught in analysis paralysis.
Our main objective today is a 10-engine static fire. Aboard. On LVN1, looks like we kicked out due to 2 combustors from the apex bank being pelted.
There was a pad side abort called. These things were holding like 6,000 tons of propellant plus the rocket weight. And it's like, okay, well, why didn't you guys simulate that? It's like, well, because we didn't have anything that weighed that much. Like, this is the first time we put anything on it that weighed that much. So there's just so much that you have to think about and then be very paranoid on.
We kicked out early. All teams triage alerts, prepare for offload.
We actually had another pad abort on the diverter.
Basically, right during engine firing, it was so much noise and vibration that it actually shook the sensors that are located out in this area enough that they aborted us out of the test. We went back, obviously, afterwards and looked at all the data and tried to come up with smarter ways to basically still protect the integrity of the diverter throughout the operation while changing our parameters so that we were making sure that we would not abort again.
A flame diverter is like a super simple concept that is like not at all complicated in operation and is just absolutely murderous in the details. These are extremely sophisticated thermal load sensing devices. If they turn into melted metal slag, then you know that you got too much heat. If you melt this, you're hotter than aluminum melts. If you melt this, you're hotter than zinc melts. If you melt this, you're hotter than copper melts. If you melt this, you're hotter than Sharpie melts. So we're sub-Sharpie. We have all of this mass flow, all of this energy that is just absolutely trying to obliterate our pad. We want to give it a thing to obliterate, to keep from obliterating the things that we care about. And the thing we give it is water. The amount of energy that water can absorb is like miraculous. And so if you can get high enough pressure water in the right places and just allow it to flash boil that water, then it solves a lot of the problems for you. Like the idea is that the steel never gets that hot, the structures never get that hot, because the water absorbs all that energy, turns to steam, and everything's okay.
So for this flame deflector on pad 2, we're sitting somewhere in the neighborhood of about 650,000 gallons per minute. That's approximately in the range of about like one entire Olympic swimming pool being drained in the course of a minute.
You're trying to look into this thing and you see how like glowing hot it is. It's just yeah, a pretty impossible environment to keep something happy in. But then you zoom in and the flame deflector's still there, so that's the reason we build those things.
Putting the rocket into human terms is something really tough. 65,000 pounds per second of propellant that is coming out of the engines. And again, just like 18 million pounds of thrust, like what does that number mean? I think of like 11 Ford F-150 trucks per second just zipping out of the bottom of the rocket. It's like imagine if you had the world's biggest machine gun, except for instead of shooting bullets, it was shooting pickup trucks, and it's just firing 11 pickup trucks per second out of the bottom of the rocket. It's like, do you think your stuff could survive that?
For the last, week or two, it's mostly just been running on stress and caffeine because we had so many things that we were trying to incorporate, and there's just a lot riding on this test. The previous test that we did not achieve enough duration such that we had the engineering data that we needed to be confident moving into flight. If not able to get this test off successfully today, then we're pushing launch day for day, which is an extremely big drag on the entire program and all the engineering teams involved. So there's always pressure going into an op, but this one is particularly high.
This was a big day, the 4th attempt that we've had for a static fire, and we finally went full duration on all engines, so feels really good. I'm super relieved. Again, it was like pretty dynamic, and having done this 4 times now, it's like, man, what else can go wrong here? Because we just haven't seen the vibration and the temperatures that we're about to be subjected to.
We've never connected the QD to a vehicle, and we've never flowed propellant into a Starship on pad 2. So although this was a really big milestone, the next step is to prove that those systems work in the way that we designed them to.
We designed this pad to be able to support a launch every 60 minutes indefinitely. The thing about pad 1 is it was designed to be very quick to build, it was designed to be very cheap, and it was designed to give good access to the aft end of the booster. The reason all of those things were a design goal is because we sucked at building Starship pads and we sucked at building Starships. It's like we didn't know what we were doing because it was impossible to know what you were doing because no one had ever done something like this before. The brief on that one was, hey, get something up very quick and very scrappy and very inexpensively, but that's okay. It actually needs to just be good enough for us to learn. And then if we can learn from it, we'll go build the actual good thing. I mean, the integration mechanism is the pad. The catch mechanism is the pad. All of this stuff is like integral to how the pad operates. And so the reason we call it stage 0 is literally it is the first stage of the launch process. And if it is not working, we cannot go launch. And so that certainly like raises the stakes and raises the priority and like drama whenever things go wrong on the pad. Post-static fire, as we were transiting the chopstick arms back to a lower position, we heard a loud noise out at the pad.
It's vibrating the entire tower. Something got jammed up in the chain and maybe it caused it to snap. We don't really know if it's broken completely or if it's just cockeyed or buckled in some way. God, it sounds terrible. So we are in a mad dash to get that roller diagnosed and replaced as soon as possible.
The chop carriage has many rollers positioned at different parts around the tower. And when I say roller, it's literally like, imagine the world's largest bicycle chain. It's built almost exactly like a bike chain, except for it's 380 pounds. And the chop carriage weighs a lot. And so it basically broke one of those links. The chain got bound up. And the day after static fire, we called our buddies at the Cape. We had some spare units over there for building the Cape towers. We're able to hot shot to overnight the chain to us. Got the old chain torn apart, got the new one put together, flew it up, and the morning after that, we were ready to rock.
Hey, with these ones, make sure we're going up. Arriba.
It was on the order of like 30 hours, 36 hours from we found the problem to had it fully back in service. On like an item that was not really designed to be very serviceable. To be able to come up with a scrappy plan, you know, temp support it with cranes, get in there and boogie is like, that's like just classic SpaceX nonsense.
Tower courier, you go?
We're still go for tomorrow, but it's like a very, very tight schedule.
We're basically in a race with the ship right now.
Switching in 3, 2, 1.
All
When you get off.
All right, chopsticks are moving. Come on, baby.
That's crazy. What a day.
The purpose of this mission is to collect some really high-profile imagery of the Starship, specifically its heat shield, after re-entry. This is the most in-depth operation that we've ever conducted. We'll be having the most buoys with the most equipment and way more drones than we have ever had to have offshore. This buoy right here has been used since Flight 5. We deployed these buoys kind of like as a Hail Mary attempt. They were very scrappily, but, you know, as well as they could be put together. It was almost miraculous, even in the middle of the night, to see all of these buoys pointed directly at Starship as it was landing. And gradually from flight 5, 6, 7, and onwards, these have always been deployed. While it does get punctures, we can patch them as needed and kind of give them the Band-Aids that they need in order to keep kicking.
We just departed the port here at Exmouth. I think we've got about a 2.5 day transit, 500 nautical miles, up to a 21-day voyage out to the Indian Ocean.
We will be getting a full, almost 3D model of the vehicle at different points of re-entry and landing that will allow us to not only assess the performance of the vehicle for Flight 12, but build a new and better Starship.
It's weird the things you find yourself getting good at in your quests to go to Mars or the moon or fly a bunch of satellites. And something we are really good at as a company is just moving big things.
There you go, looking good just like that. Yeah, you hug this left side, you'll be good on your right side off of the building.
So we have a whole team of people, the CLT, the critical lift team.
Good to roll forward.
And their job is just to move, to maintain, to operate equipment and infrastructure to move heavy things all around.
V19 is now entering Highway 4. All of the great people of Starbase watching V19 roll out to the pad.
We wanted to make sure we made it down here for the first version 3.
I was here for Flight 9 and 11. I got to see the catch. You don't get to say that every day.
Honestly, just seeing V3 take flight, it's been a long wait, and also the flame trench is going to look pretty awesome.
Looking good on your left side. Keep on rolling. Rolling, rolling, rolling.
Just out here to watch the V19 roll out with my family visiting Starbase. It's just cool to see everyone working at SpaceX together to push forward humanity's future.
Got a beautiful line like that. We'll keep walking in just like that for a little bit. All clear in the front.
And so they move our rockets. They are like, I mean, absolute pros at just give them a random, ginormous shape and say, this needs to get from here to there, and they'll go do it.
Gonna keep it nice and slow.
So right now we're in Star Factory and we're doing the final preparations to load the imaging satellites into our satellite speed loader. This is the last step that's going to happen before we send the satellites over to Mega Bay 2, where they're going to be loaded into ship and prepared for flight. So these 2 satellites will be just 2 of 22 total deployed objects. The other 20 are what we call satellite simulators. They don't have computers on board or anything like that. They're really just hunks of steel that mimic the shape and weight of satellites approximately. It helps us test the PES deploy system. We're also going to be inspecting the more sensitive components of the satellite, the laser optics that send data to other satellites, the thruster on board for on-orbit maneuvering. All of those systems are more sensitive to things like FOD or dust, so we want to give them one last inspection before they go in to make sure they're ready to go to space.
Okay, Bennett, just confirm for us that you are ready for us to lift the next satellite.
We've finished the profile, everything looks good. I'm gonna disable now, so they'll be good to remove rigging.
Copy, standing by. All 22 of those objects are going to mass up to about 37.5 metric tons. That is heavier than any payload Falcon has ever launched. I believe this is the heaviest payload SpaceX will have launched ever, so we want to learn as much as possible about the PES system and how the satellites interact with it. We're on that suborbital trajectory, but it shows the capability that Starship has for future orbital missions coming up.
it's amazing. Like, I mean, even just standing next to it, you're already in awe because it's something that is such a magnificent sight to see.
People have worked very hard for very many years on this. It's the third evolution of the fully and rapidly reusable launch vehicle that SpaceX aims to develop.
I started when the tents were here. It's just tents and dirt. We've come a long way since I started here as an intern a couple of years ago.
I mean, it's the biggest thing ever launched, so there's nothing that can match it.
I expect it to be loud and fast. It's definitely going to rock the city of Starbase.
Yeah, I was thinking, like, why the tower team has these big crises always, like, right before we have, like, a big operation. I think it has to just do with the scale of everything. Like, we have these big, complicated mechanisms that, like, need to work right every time we use them. And just replacing a roller turned into this several-day ordeal with flying shit in from the Cape, 3 cranes to get it in and out, where, like, if this was a broken bearing on some little dinky electrical motor, it would have been much easier to make that swap in an hour instead of 24.
I feel like it also set us up for success in terms of like the getting mentally ready to act on immediate. So super exciting time tomorrow. Hopefully we see the fruits of our labor sort of culminate in a great successful flight.
No, it looks good. Let's get into safing so we can extend the platform space.
After this, we'll transition to preload for on-latch, take the HP to integrated ops, take it for flight, and then we'll do a quick go-no-go poll. I'll give you a countdown and we'll start releasing.
Holding at T-minus 40 seconds.
This looks like a blip on blind pressure when we unpinned. Pressures and preloads are healthy.
Yeah, it's hard to tell. This is all fogged up from cryo, but it's essentially right there. Guys, I recommend we release hold and give it one more chance to unlatch with where we're at.
Ship XYs are not going to close out and damped, but I believe that's okay.
Okay, we have just enough time on the vehicle to attempt one more time, so I recommend we clear the hold, let it try to unlatch it at the 100 bar we're at.
We're still stuck in dampening though.
Understood, we'd be reattempting with the same hydraulic pressure. Cool, this will be our last attempt and then we're done on the rockets.
Unexpected drop in Z-cylinder blind pressure when we unpinned.
That was different from the first few tries?
That's correct, different problem.
Copy.
Yeah, this might be due to QD arm dynamics when we unpin, so I don't think trying again is going to solve the problem, to be honest.
We're done for flight for the day. Flight. Thank you.
Mechanical systems really come alive in that last 40 seconds. As a part of that sequence, one of the things that we do is we unpin that arm so that the QD can swing away and not blow itself up as the rocket flies away. And that part of the arm is pushing hard against the tower while we unlatch to make sure that even if there's excess pressure or anything like that, that the QD stays really tight up against the ship. And the first time that we had unpinned that arm in flight-like conditions was that attempt. So as we retracted that pin, the arm wanted to shove closer into the tower. It caused the end effector to kind of jiggle back and forth very slightly. That jiggle set off some really tight, sensitive bounds that we had on the hydraulic system out there. And you need it to work, or else the rocket doesn't fly, so.
Always be paranoid. Going into this flight attempt, we were worried about a completely different thing, which was the hold for the actual vents on the fill drain. And then those passed, and then we got bit by something completely different. So you gotta be paranoid about everything.
Last night, overnight, we did a sweep of our 30 nautical mile hazardous no-go zone to make sure there's no vessels. Range is currently clear. Everything's looking good. It's a little rough out. It's 1 o'clock in the morning. Doing final preps on all the buoys, getting all cameras online. This is when it all happens, at 1 o'clock in the morning.
This is the most important mission we've done out here. We're putting in the most buoys and the most drones. So if we don't have this data, the people back home have no idea how the heat shield really performed.
Sren, do you want to give it a final kiss goodbye for good luck?
That was a wet kiss.
Perfect.
Beautiful.
All right.
Bye-bye, buoy.
Good afternoon, welcome to the Starship Flight 12 Attempt 2 weather briefing. Starship range is currently green.
Tower Kenny, are you up on countdown 1? Can you give a brief on what we did last night for the QD arm situation?
So the cause of yesterday's abort was that the ship QD arm had dynamics when we tried to unpin it due to the preload that the ship QD mech was pushing into the vehicle with. The mitigations that we have in place today are that we've welded a hard stop bumper to the ship QD arm to limit the amount of displacement that can occur when the unpinner unpins.
Attention all flight crew members, on countdown 1 is the final go, no-go poll for today's operations. RC?
Go.
Ground stations?
Go.
Flight software 1?
Go.
Raptor 1?
Go.
Raptor 2?
Go.
Stage 1?
Go.
Flight directors go as well. T-minus 1 minute. Holding at T-minus 40 seconds.
SpaceXers really are at their best in ASAP mode. We do a good job of not being afraid of putting ourselves in a really tight spot.
Fill drains are go.
Copy. SC1, reset the operator hold.
Reset. Clock is rolling.
People hate pain, and that ability to absorb pain for change here at Starbase is like unparalleled. And if you just are willing to take a little bit of it, you can do the most amazing things.
Flight directors go for launch. T-minus 10, 9, 8, 7, 6,
Okay, here we go.
5, 4, 3, 2, 1. Ignition. We have liftoff.
execute. Change separation. Acknowledging many booster alerts.
5 engines on boost back startup.
Flight software acknowledging mission abort, earlier boost back shutdown. Expected.
Yes, sir. Can confirm. Exec team is aware that a booster did not make it to the final landing location.
Ship avionics, power and telemetry nominal.
We have healthy chamber pressures on 5 out of 6 ship Raptor engines.
We're deploying sets.
That was the coolest thing I've ever seen. Wow. Yeah, video of a satellite looking at our ship. This one was good.
Starship is turning for final approach to landing site. Starship has landed.
The hottest things humans have ever done, honestly.
It feels like it.
Yeah.
This might be our crowning achievement. After this, the robots will have to take over. Exactly.
Anytime we have these kind of big evolutionary leaps in the program, whether it was the very first Flight 1, whether it was first catch on Flight 5, obviously new major block change with the pad and the ship and the booster all at the same time for V3, there's somewhat of an expectation of like, what might we have missed? But at some point, you just got to say, hey, the most learnings are to go fly.